Hello everybody. For this video, it's going to be sort of an introduction to functions, and the idea is before we can really learn about Algebra 2 properly, we need to have an understanding of what functions are. And when I teach abstract ideas, I like to have some real-world context so that we can think about abstract ideas in a more concrete way. So that's what I'm going to do here. You see, we have some abstract terminology like variables, relations, functions. We have independent variable and the word domain, and we have the dependent variable that goes with the word range. And these are all abstract ideas, but if we talk about them in a context, we might understand them better. So without context, we should know that variables are quantities. They're numbers that can change. If you pair two variables or more together, that can cause a relation. And functions are special kinds of relations, and those are going to be the kinds of relations that we're going to study this year. Functions can have more than two variables, but for this course, we're primarily going to focus on functions that have two variables. The first variable will be the variable that you can control. It's called the independent variable, and then the dependent variable will be some quantity that changes as a result of a change in the independent variable. For example, we can have a scientist who's testing the effect of light and dark on the behavior of moths. By turning a light on and off, the scientist could also turn the intensity of the light up or down. The independent variable in this case then would be the amount of light, and the reaction to the light will be the dependent variable. Now, we can measure the reaction by how much the moth flies or the number of wing flaps per second or per minute or something like that. So that can be quantifiable, a reaction as a number of wing flaps per minute, we'll say. Another quantifiable variable would be the intensity of the light that's shown on those moths. So the independent variable, again, intensity of light. The dependent variable is going to be the speed at which the moth's wings flap as a result of that light. Now, we have the words domain and range. The domain refers to the types of numbers we could expect in the independent variable. Here we're talking about intensity of light, so a light is off would be 0 intensity, and then we could say that 100 represents maximum intensity, and then we could rate the intensity on a scale of 1 to 100 to determine how bright or dim the light is. So our domain would be any number from 0 to 100, representing light intensity. And as I mentioned, the range is going to be part of the representing the dependent variable, and that we're going to say is the speed of wing flapping. So a moth that does not flap at all would have 0 beats per minute, and a moth that's going crazy could have, let's just say for the sake of argument, 60 beats per minute, which is actually really slow. But I can't come up with something at the top of my head. So once again, we could say the domain are the numbers that are associated with the independent variable, and in this case could be 0 to 100 light intensity, and the range are numbers that are associated with the dependent variable. In this case, it would be 0 to however many flaps per minute we would be looking at. Here's another example. If you're interested in average high temperatures in Wisconsin, you would understand that the high temperatures change depending on the day of the year. So each day of the year is represented by the independent variable because the days of the year happen whether we do anything or not. But the temperature in Wisconsin is going to be determined by what day of the year you have. A day in July is going to have a higher average temperature than a day in January. So the independent variable is days of the year. The domain would be any number from 0 to 365 because there's 365 days in a year. The dependent variable will be the temperatures, the average high temperatures in Wisconsin. The range would essentially be the coldest we generally get in Wisconsin, let's say negative 10 degrees on average. That's a little low. But then the highest average temperature could be like 85 degrees. That would be the average high in the summertime. So the range would be numbers from negative 10 to 85, whereas the domain would be numbers from 0 to 365. So I'm talking a lot about this. It's been a good 4 minutes into independent variable and dependent variable, but I would like you to think about these contexts in order for you to be able to understand the relationship between the independent variable and the set of numbers called the domain compared to the dependent variable and its set of numbers called the range. We'll look into domain and range a lot more later, but for now, I want to move on. the language of functions. We use the phrase "is a function of" in the mathematics world to pair variable relationships together. So, for example, we could talk about hair length. It's established that hair length is a relation. That relation is a function because there's only one hair length for every moment in time since your last haircut. So if it's been a day since my last haircut, I will have a certain hair length, and if it's been 100 days since my last haircut, I will have a different length, and we can expect that that length is going to change as a result of time passing. So we can say that the length of the hair depends on how long it's been since the hair was cut. So we can say that the hair length depends, therefore is the dependent variable, and the time since the last cut is the independent variable. Now, to describe all of this in one sentence, mathematicians have developed a specific language. Instead of the whole paragraph above, I can simply say the phrase, hair length is a function of the time since your last haircut. When I say is a function of, I can think depends on. So hair length depends on the time since your last haircut. Hair length, therefore, is a function of time since your last haircut. Earlier I mentioned average temperature. We would say the average high temperature in Wisconsin is a function of the day of the year, because the high temperature average depends on what day of year it is. We could discuss the quality of the diamond. The price of a diamond is a function of its weight in carats. That means that the price of a diamond depends on how heavy it is. The heavier the diamond, presumably the higher the price. So these are all examples of is a function of language, and what you see is I'm translating from the way we normally think about relationships to the way mathematicians speak about those relationships. So, simple assignment for today. I'm just going to ask you guys to read each of the statements below. I'll do the first one with you, but for each statement you are going to identify the variables, determine which one is independent, and then write a function of statement to go with it. So, for example, in the first one it says, the heavier the envelope, the more expensive the postage cost. So first I'm going to define my variables. We're going to have weight of envelope. And now notice, I did not say that my variable was the heavier the envelope. I have to change the phrase the heavier the envelope into something that's quantifiable, like weight. So the weight is a number that we can measure, so the weight of the envelope is one of the variables. We also have a second variable, which is the postage cost. Now, since the postage cost is going to be determined by how heavy the envelope is, we will indicate that the weight of the envelope represents the independent variable. Then obviously the postage cost will be dependent on the weight. To translate this into function language, we simply start by looking at the object of our study. The interest we are in here is the cost. So postage cost depends on the weight of the envelope. We're going to say is a function of. And then we would put the weight of the envelope. The envelope. So you can see that I had 3 tasks. The first is to identify from this sentence 2 quantifiable or countable variables or measurable variables. So I took the heavier the envelope and turned that into a weight variable. And then I turned postage cost as a cost variable. And then I determined that the weight is what controls the cost, therefore the weight is the independent variable. To make an is a function of statement work for you, you'll always have the dependent variable first. The dependent variable depends on or is a function of the independent variable. So if you're doing this right, your y variable, your dependent variable would be first, and your independent variable would be the last part of the sentence. Here it should be easy to quantify. It says as the radius of a circle gets bigger, so too does the area. So the area of the circle is one variable. The radius of a circle is another variable. So your job would be to first identify the variables like I just did, say which of the 2 represents the independent, and translate. do the same for each of the remaining sentences here. This worksheet will be available in Google Classroom. So thanks for being patient through the video. Thanks for watching, and have a nice day.